Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
All right. So in this problem, so we have the incline and we have a block, and the worker is pushing this block. So the block is moving down with a constant velocity. So v is a constant. So the constant it moves down with a constant velocity means that the net force on this block is actually equal to 0. So for part A, we want to find out the force initiated by the worker. So if we do the force analysis, so there is a gravity, and this is the component which is parallel to the incline, and this is the component which is perpendicular to the incline. So for this component, it actually equal to mg times sine theta, where theta is this angle, is the incline angle. So to cancel out this component, the worker has to perform a force with the same magnitude but opposite direction. So just point to this direction. So this will be the force exerted by the worker. And you can plug in the values. So m is 45 kilograms, and g is the gravitational constant. Theta, we do not know theta, but we know the geometry factors of the incline. So length of the incline is 1.5 meters, and height of the incline is 0.91 meters. So sine theta will be equal to 0.91 over 1.5. Okay, so we can actually find out F worker equal let me see, negative uh, yeah, 270 newtons. Okay, and for part B, we want to find out the work done by the worker. So the work done by the worker, we can simply utilize the definition of the work. So Fw times S. So where S is the length of the incline, which is 1.5 meters. So this is S, and Fw is the one we found previously. And because the force is pointing up and the velocity is pointing down, so they are opposite. So we have a negative sign in front. So this value is negative 401 joules. Okay, 401 joules. And for part C, you want to find out the work done by the gravity. It's yeah, this is the W worker. This is Wg gravity. So this will be equal to the gravitational force times the displacement on the y component. So which will be d times, let me see, sine theta, right? So not d, sorry. Right. So the displacement on the y component is basically just the height of this incline. So we just use h to label the height times h. Okay. One more equal sign. So we already have the height here. So just plug in the values, and you'll see that this equal to 401 joules, which is just the opposite to this value. And for part D, we want to find out the work done by the normal force, Wn, because normal force is pointing up, and it is perpendicular to the incline. So basically, the work is simply 0 because the displacement and the force, they are perpendicular. And for part E, you want to find the work done by the net force, W. This is the norm, and this is net force. Okay. Because the block is moving with a constant velocity, so the net force is 0. If the net force is zero, then net work is zero.